Welcome to this video on how to perform PCA in R. Principal component analysis is a technique used to reduce the number of variables in your data while retaining as much information as possible. The goal of PCA is to find new axes, or principal components, that capture the maximum variance in the data while reducing dimensionality without losing too much information. So let's go ahead and load in this data set. This is a built-in dataset called Iris. It includes 4 variables: sepal length, sepal width, petal length, and petal width. Now let's go ahead and run PCA on this dataset. Before we run PCA, it's important to scale the features, especially if they're on different scales. So here we set scale to true. Here are the results. So based on the importance of components, PC1, or principal component 1, captures nearly 73% of the variance in the data. PC2 captures another 22%, and cumulatively they capture 96% of the variation. Here are the eigenvectors. So these show how much each original variable contributes to each principal component. So each column is a principal component, and each row is a variable. So here we can see that sepal length contributes quite significantly, as does petal length and petal width, while sepal width does not contribute as much in the first principal component. However, it does contribute significantly in the second principal component. Now let's go ahead and look at a scree plot which shows the level of variance explained by each principal component. So here we can see that the first principal component explains a significant amount of the variance. Now let's go ahead and run a biplot which shows both the data and loadings. So here we've plotted both the first principal component and the second principal component, and we can see the directions of each variable within the data. Now let's go ahead and visualize the scores generated by the principal component analysis, and we'll do this using ggplot2. So this is the principal component analysis of the Iris dataset, and here we've plotted both principal component 1 and principal component 2, and the data has been categorized by the different species of flowers. So the first principal component explained much of the area here using the variables such as sepal length, and petal width, while sepal width explained much of the area here in principal component 2. And that's how we run principal component analysis in R.